Three students S1, S2 and S3 are given a problem to solve. We have 4 events. U is at least one of them can solve the problem. V is S1 can solve given that neither S2 nor S3 can solve. Whereas W is S2 can solve the problem and S3 cannot. For T it is S3 can solve the problem. And we have probabilities, which is P of U equal to half, P of V equal to 1 by 10 and P of W equal to 1 by 12. We need to find the value of probability of T. Now let us assume the probabilities of S1, S2 and S3 are X, Y and Z respectively. And now let's take the event U, which says that at least one of the three can solve the problem. It can be represented as probability of U equal to probability of S1 union, S2 union, S3, which can also be written as 1 minus probability of S1 bar intersection S2 bar intersection S3 bar, which is equals to half. It implies that probability of S1 bar intersection S2 bar intersection S3 bar equal to 1 minus 1 by 2, which is equals to 1 by 2. It also can be represented as 1 minus x multiplied by 1 minus y multiplied by 1 minus z equal to 1 by 2, and we give this equation number 1. Now let's go to event V, where S1 can solve the problem given that neither S2 nor S3 can solve the problem. So P of V equal to P of S1 given S2 bar intersection S3 bar, which can be written as probability of S1 intersection S2 bar intersection S3 bar divided by probability of S2 bar intersection S3 bar. It can be written as x multiplied by 1 minus y multiplied by 1 minus z divided by 1 minus y into 1 minus z, which is equals to 1 by 10. And now we cancel common terms in numerator and denominator, which implies that x equal to 1 by 10. And we give this equation number 2. Now we substitute this equation number 2 in equation number 1. And we get 9 by 10 multiplied by 1 minus y into 1 minus z equal to half. From this we get that 1 minus y multiplied by 1 minus z equal to 5 by 9. And we name it equation number 3. And now coming to event W, wherein S2 can solve the problem and S3 cannot. And the probability of W is 1 by 12. So probability of W equal to probability of S2 intersection S3 bar which can be written as y multiplied by 1 minus z. And it is equals to 1 by 12 as given in the question. Now we name this equation number 4. And now we divide equation number 3 and equation number 4. So equation 3 divided by equation number 4 implies that 1 minus y into 1 minus z divided by y into 1 minus z equal to 5 by 9 divided by 1 by 12. So we cancel the common terms and we get 1 minus y divided by y, which is 1 by y minus 1 equal to 5 by 9 multiplied by 12. By cancelling we get that value as 20 divided by 3. And now we get 1 by y equals to 20 by 3 plus 1, which is 23 divided by 3. And y is equals to 3 divided by 23. And we give this equation. Substitute equation number 5 in equation number 4. That is y multiplied by 1 minus z equals to 1 by 12, which is 3 divided by 23 into 1 minus z equal to 1 by 12. So we get 1 minus z equals to 23 divided by 36. That is z is equals to 13 by 36. We are asked to find out the value of probability of t. Probability of t is probability that S3 can solve the problem. Probability that S3 can solve the problem is z. So the final answer is P of t equal to P of S3 equal to z, which is equal. It is 13 by 36.